Okay, so just as a recap, because it's been a while, remember for the standard, the calculations, you go to the home page, click on content, and you'll then go to the scroll down till you get to this one. Now, do not go to any of the modules, just simply go to the introduction. You will have to go to the modules to get the teacher marked assignment. They will eventually all be available on this first page, but at the moment it's only the booklet. So you work through the booklet. This is your preparation. Otherwise, you don't work through the module. Now that you've done all that, what we're going to be focusing on now is an exemplar of what you will be doing in the assessment task. So there's two parts. There's a part that you do beforehand, before you go. So I know, for instance, the Hamilton Chemistry Day is at the end of June, 29th of June, round about there. So try and be prepared for that if you're going to that one. I'm not sure about when it's happening in Christchurch, but I know for Auckland, you need to contact Babita. That's all up there. If you can come to Wellington, then you come contact me. Right. So just as a reminder, you will be given these formulae. So what you need to know is what they represent. So you need to know that N represents amount, which is measured in mole. Small m represents mass, which is measured in gram. And big M is the molar mass. And you will be given the molar mass, as you'll see in this practice assessment exemplar. And that's measured in grams per mole. Then this formula is C for concentration. And then we have N, which is, you'll notice, the same as that N. So this is the way you connect between the two formulae. So this is the amount, and V is volume. Now, volume, the unit is liter. So be very aware of that, because in the titration, we're going to be using milliliters. So you have to always convert to liters. Otherwise, you're not going to achieve. Okay, then we look through very briefly of this whole process and why we do this whole process. So what we have here as our exemplar is we have this muriatic acid, which is just really HCl. It's an old name for it. And, oh, that was supposed to be 3.2%. Okay, not 32%. So it's 3.2%. So that would be like the standard concentration you'd use to clean bricks. You don't have to dilute it. In shops, I must admit, it's normally 10 times more concentrated, but we're going to use the more diluted version. But it's still too concentrated to use for a direct titration. So in order to work out whether I really have 3.2% HCl in my muriatic acid, there's a number of steps we have to follow. First, we have to titrate, seeing this as an acid, with a base. Now, the base that's normally used is sodium hydroxide. But sodium hydroxide is not a primary standard because it combines with carbon dioxide in the air, combines with water in the air. So I need to first work out the exact concentration of my sodium hydroxide. And so I'll do it by titrating it with a primary standard. So something that's very stable, very pure, so I know exactly what the concentration is. So in the first part of the assessment, and we did this in a previous lesson, you do this bit. Now, you don't actually do it in the lab, you just do it in theory. So you work out the concentration of this, you titrate it with that to work out the exact concentration of the sodium hydroxide you're going to be titrating with. Then we take our muriatic acid, see Can I titrate directly or do I need to dilute? And you will need to dilute, I can tell you that now. So we need to work out the dilution factor of how much we need to dilute it by to titrate with the sodium hydroxide. Then we do that titration. Now that titration is done in the lab. Okay, so all this part you need to do beforehand, and it's covered in the CHO 2112Y1, which is a calculations assessment that you sit at home. This bit over here, you do some of this in the CHO 2112Y1 as well as in the lab, and you need to get either one of these correct, okay, in order to achieve. This one's the more complicated version. So most people, get this one ticked. That gets done in the lab. So you start with this in the lab, and then you do the rest in the lab, and then you finish it off at home. So that's the overview. Any questions so far? I know we did look at that before, but it's been a while since we did that. So you all okay? There is a chat button at the top if you want to type in. Otherwise, if you don't mind your voice being recorded. So this is exactly what you would get, obviously with a different substance or different amounts in the 2112Y1. You get told how much is weighed out and how much it's dissolved in. So you need to work this out. Now, I have done this in the previous lesson, so I'm not going to do this again. Then this is the titration part, the step 2. And then you work out the exact concentration of the sodium hydroxide. Now, this is where we get the dilution, where we can do it in the lab or we can do it doing it theoretically like this. So when you want to work out the dilution, and I know we did do a bit of this, but we'll just do it over again. The first thing you need to do when you want to work out that dilution is convert this unit, which is a percentage unit and means grams of HCl in 100 milliliters of solution. We want to convert it to moles per liter. So the first thing you do is when you work this out is you say, okay, if it's 3.2%, I've got 3.2 grams in 100 milliliters. Now remember, we don't want milliliters. We want everything in liters because our unit is liters. So if I've got 3.2 grams in 100 milliliters, can you see I will have 10 times that amount, so 32 grams in 1,000 milliliters. You all see that? If I have 10 times the volume of solution, I'm going to have 10 times the mass dissolved in it. So now that I know G, so this is where it's really useful to know the formula, go back and look. N is equal to small m over big M, and C is equal to N over V. So what we want is we want to calculate the concentration in the moles per liter. So this is what we're looking for. And so now you've got to think, what have I been given? I have been given the 3.2, which is the 32 grams. Now, grams is a unit of which quantity? N, M, big M, or V? Would anybody like to put it into the chat? Mass. So I know this, okay? Now what, and you were given up here, so have a look because it may not be that obvious, but can you see up here? So you may find in the assessment task, you might have to look a little bit. It should be always by a question, but sometimes it might be a little bit higher up. So don't just look immediately over here. Can you see we know the molar mass of our HCl. So this is all to do with HCl. Remember, these formulae can only apply to one substance. So N must be for HCl, small m must be for HCl, and big M must be for HCl. So I can now work out my unknown N. And if I know that N, I can work out this N. I already know V, if I change the color of this again, because you'll notice my V is over here. So I already know V. And sorry, milliliter, don't say 1,000 because you've got to convert milliliters to liters. So that is equal to 1 liter. Okay, so V is actually 1 liter, not 1,000. So I'll just remove that just in case you get confused. Because remember, you've got to have the right units. So now you would just simply substitute and you would go first this one, N is equal to small m over big M. Try and give all your formulae, then the substitution, then the answer, because if it's just a mass of figures and you've made a mistake, the teacher doesn't know what you've done. But at least if you said N is equal to small m over big M and then you substituted, the teacher can follow your logic. So we've got 32 grams, all over 36.5 grams per mole. And so that is going to be equal to 32 divided by 36.5. I get an answer of 0.8767. Okay. 8767 mole. Remember your units. Okay. And that'll all be in 1 liter. So if I now did, and I'll just change the color so it stands out more clearly, C is equal to N over V. So it's really 0.8767 over 1 liter. So my concentration, and I'm running out of space, you must look at what you are told. I need to give this answer to 2 significant figures. And that's because that was given to 2 significant figures. So will my answer be 0.8767? Will it be 0.87? Or will it be 0.88? The first answer with all 4 figures. The second answer where it's just 0.87. Or is it the third answer? You can just say 1, 2, or 3. Is it 0.88? 0.88. And the reason that is totally correct, and the reason is because this number over here is 5 or greater. Let me just put it in yellow. So that will make the 7 go to 8. So if it was 0.875, whatever, you would still take the 7 and up to the 8. But keep all the figures in your calculator, okay? Because if you when you continue rounding or carrying on, you want to make sure you've got as accurate figures as possible. So that would be now mole per liter. So whenever you've finished a calculation, remember the 3 steps. Have I got a unit? Okay. Have I got the right number of significant figures? Is my answer sensible? Now, in this case, you can't really see whether your answer is sensible or not. You know, but if you had something weird, if you had something like 50 moles per liter, then something is weird because the concentration of water, so the concentration of water in water is 55 moles of water molecules in 1 liter of water. So pure water has a concentration of around about 55 moles per liter. So you never want to have such a high concentration because that's not going to be right. Okay. And if you had also very low 0.0000 something, you know it's got to be more than 0.1 because you know you've got to dilute it. So you're not going to, if it's 0.01, you're not going to dilute it more because you want to react it with a 0.1 mole per liter sodium hydroxide. So you're expecting something more than 0.1 so that you can dilute it. Does that make sense? Okay, I hope so. Right. So now here, this just helps support your answer at the very end when you go home after the lab and you do a write-up of the report. You have to explain why you actually had to titrate it. And the reason why I can't take my 0.088 mole per liter of hydrochloric acid with 0.1, if I had 0.88 mole per liter HCl, and I was titrating it with 0.1 mole per liter NaCOH, because if you look at the formula over here, it's a 1-to-1 ratio. If I used volumes and I used 25 milliliters there, I need to use approximately 25 milliliters here. As you can see in the intro, we said it's got to be approximately 18 to 30. If it's too small, it means every drop will make a big change in your titration. So you can go past the end point very quickly, okay? And so you won't be accurate. If it's too dilute, a little drop is not going to do much. And eventually, if it's too dilute, you won't, the color change will be very slow. And it's a bit like, put a frog into boiling water and they'll jump straight out. But put a frog in cold water and heat it slowly, they won't notice the change. So you don't want something too dilute. That's going to use, where a drop of solution is really not going to do much. So you want to have it as close to 25 mils as possible, but you can have a bit less or a bit more. So basically to get an accurate titration, you want to have similar results or similar volumes, I should say. Now, can you see that is nearly 10 times the concentration of that? So I'm only going to be using about 3 milliliters of my HCl solution to neutralize 25 milliliters of my sodium hydroxide. Now, you don't have to write it all out like this in this briefly explained part. If you were going for excellence, you would do this at home. I've got a Wacom tablet. So I do have a screen that I can write on, but then you're going to see my arm always writing over there. So I just have connected up a Wacom tablet and then I've got a pen with that. And you just learn to look at the screen while you're writing down here on paper. So you don't actually look at what you're writing, but you learn. That's why my writing is so terrible. Okay. So you do need to say something along those lines. It's really, you want to make your titration accurate. If your solution is too concentrated, a small drop is just going to make too big a change, and so you'll shoot past the endpoint very quickly. Okay, now we get to this part, and this is what you need, and you'll get exactly the same thing again in the second part when you come to the lab. But it's basically when you say, okay, how much must I dilute it by? So here we are doing it theoretically. In the lab, you're going to do it practically. You're actually going to be mixing the solutions and seeing how much base you need to add to neutralize the acid. So here we'd basically say, okay, how would I make a 250 ml of diluted HCl solution using my 3.2 hydrochloric acid? And with, trying to do it with a 0.1 mol per liter sodium hydroxide solution. So you've done most of it over here. You'll say your undiluted HCl. The C was equal to 0.88 mole per liter minus 1. And that's approximately 10 times more concentrated than 0.1, because it's around about 0.9, which is close to 10. I know it's not exactly, but it's approximately. Now, you are only given certain equipment. So which one of these will give more or less the closest ratio? There are two options I can use, but let's start with the one that I definitely can't use. Can I use 10 milliliter of solution of my undiluted and dilute it up to 250? Will that get my solution, my diluted HCl, will it dilute it about 10 times, or will it dilute it more than 10 times? So it might help to visualize what's going on. I've got my conical flask, not my conical flask, my Erlenmeyer flask, and I want to dilute this. So it goes up to 250. Now, do I put in just 10 mils of my HCl and fill the rest with water? Or do I do 20 mils, okay, and fill it up? Or do I use 25 mils? Did that change color? Let's do another color. Okay, that's not a very good representation. That looks nearly half full. But can you see what I am trying to do here? I want to add my undiluted acid, either 10 mils or 20 mils or 25 mils, and I'm going to make it up with water. Now, what will be my final diluted solution, where it's going to be as close to 0.1 mole per liter as possible? Because that's what my sodium hydroxide is. So I want my HCl diluted to be as well. Yep, 25. Because can you see 25 is 1/10 of 250. So you would, to describe, you would say, and I think I did put a little thing over here. Oh, no, I haven't. Okay, so you would say you can do it by calculation, or you could do it visually like this. Pipette 25.0 milliliters of undiluted HCl into a 250.0 milliliter volumetric flask. Okay, now notice I have kept these zeros. The significant figures are important. So keep those zeros there. They are there for a reason. Okay, so you'd carry on. This means I have diluted the acid 10 times. Okay. So that would be what you would write. Now, in the assessment task, you can do this by a calculation, and in the teacher marked assignment, I show how this can be done by calculation, but here I just want to show how you could sort of get the gist in your head, but you can also do it via calculation. If you did it via calculation as well, this one could still be, well, actually, no, it won't be okay. Because that won't really work either. If you did the calculation, it would be too dilute, because this is less than 10. So you want to dilute it about 10 times. You don't want to dilute it more than that. Okay, so any questions on this? You must have this step correct, either in the lab or over here. Well, you're basically saying, the way I'm going to do it is I'm going to dilute it 10 times, because my undiluted is approximately 10 times more concentrated. And the way I'm going to do it is I'm going to take 25 mils of my undiluted acid, or 25.0 mils of my undiluted acid, and put it into a volumetric flask and fill it up with distilled water. And that means I've diluted it 10 times. Okay, you will be given a template where you just fill it in, so the keywords, where you just have to fill in these values. So don't worry about the wording too much, because you will be given it. So here is the sort of wording you'll be given. So can you see it's something very similar? So what happens in the lab now, you're going to actually do this. So you're going to pour a bit of the undiluted acid into a beaker, and then you're going to measure out 1 milliliter of that, and pour it into a small beaker. You're going to rinse it out to make sure you get all the acid out of the measuring cylinder. And then you've got to add some indicator, because if you don't add indicator, you can add as much sodium hydroxide as you like to it and nothing's going to happen. I mean, as in you can't see anything happen. There will definitely be a reaction, you just can't see it. So you can either use phenolphthalein or bromothymol blue. Then what you will do is you now use sodium hydroxide, and you keep on adding from your sodium hydroxide solution into your 1 milliliter of acid until the color changes. Okay, either it goes pale pink or it goes green, depending on what indicator you're using. And when the color has changed, you see how much of the sodium hydroxide you've used. So you just pour it into a 10 ml volume, 10 ml measuring cylinder, and you just take out of the measuring cylinder so you can see the difference of what you've taken out. And so you would fill in exactly the same amount here. So you might have, for instance, amount of sodium hydroxide added. You might have added, let's say, I'm guessing now, okay? You might have added, say, 8.2 milliliters, for example. Okay, so the ratio of the concentrated acid to the sodium hydroxide is 1 ml of acid to about 8.2 milliliters of, or that shouldn't have been vinegar, that should have been the HCl. So the approximate dilution of the acid is, again, can you see it's about 1, I need to dilute it 10 times because I need to get like a 1:1 ratio. So you would say 10 times. And how can you do this? I can do it by using my 25 milliliter pipette and pipetting that amount of the acid into a volumetric flask. And I need to choose the 250 milliliter volumetric flask. And that means I've diluted it 10 times. Any questions on that bit? Okay, so this is an important part of the achieved. Okay,